crazy, berserker. I killed it, it's murder. Go 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 crazy, berserker. Crazy.
Writers write what they know. Liars write what they wanna show. Singers sing what they told. But I know you got something else to say. A secret language, speaking in tongues. Snake like tongue tied, you on the run. Tribal dancing, I don't know what you are, you are, you are, you are. Summer floating over my heart. We're both dancing over the dark side. I don't know who you are, you are, you are, you are. You got letters sprinkled all over your body. If I join up the dots, it makes me feel naughty. I feel like I shouldn't touch. You got a no touching sign. I feel like I shouldn't run. You're blocking the exit with your life. Addicted to light, center, always in the limelight. Show ya a real good time. Oh, I know you got something else for me. A secret language, speaking in tongues. Snake like tongue tied, you on the run. Tribal dancing, I don't know what you are, you are, you are, you are.
Hello everyone, we are back on Thursday for more work on the x86 instruction decoder application that I've been working on for the past week or so. On this stream we are going to tackle the SIB byte, and once I have that working for the existing instructions that we can decode most of the variants of right now, then I will see about adding more instructions, more opcodes rather, into the set that we can decode. So if we can do mod RM and SIB as well as immediates, then I think we should be able to get most of the 1-byte opcodes working. Maybe the move stuff, I don't know, but it's worth looking into, I guess. Yeah, so I think that's what we have on the table for today. And if we run make test real quick, we can see all the tests that we do have right now are working. So I feel, I didn't break anything in the meantime. Not that I was really touching it, but it's always good to double check, I guess. And I've got the table here for the SIB byte, so we can just start sort of parsing out how we want to deal with it. I don't know if, I don't think W impacts on this at all, because this is sort of a subset of the mod RM byte. There are certain, you could think of them perhaps as escape patterns in the mod RM byte, where we are still defining one of the operands using the reg parameter, and the other one, instead of specifying one of these memory references, is going to specify an escape code that takes us to SIB, but it could be SIB with a displacement. It could be SIB with a 32-bit displacement as well. So that's not impacted by W, that's impacted by what the mod value is. And yeah, I guess since it's always the same RM value that determines whether we do SIB or not, we could refactor. The way that I've already structured it is that we have basically different if statements in each of the cases of what the mod byte value is. And I guess that's probably helpful because we would need to accept this particular entry where it's 100 binary with a mod of 1 binary, because all the other ones are SIB is 100 if RM is, sorry, it's an SIB byte added on if the RM value is 100 binary, but that pattern doesn't hold in this particular case of the mod value. So rather than think about doing the refactor first, I'm just gonna call the SIB in each of these scenarios, and we'll just know that it's an SIB with a displacement, which will come after the SIB byte. So we'll need to deal with that as well. Oh, and I don't think I am actually, okay. I just had a thought because we've got this displacement stuff. I am not handling the size correctly, which has not come up in my tests because we only have a single instruction in all of these tests. So we should do a test with a single byte displacement and a 4-byte displacement I'm just going to call it like instruction 2. So 2 instructions with disp 8, and this one will be instruction 2 with disp 32. And it's in the multi-category, I guess. I don't know, the naming convention that I have right now is kind of bad. But I don't have a good story for that at the moment. So I think if we have everything is 2 bytes for the full instruction in these. Let's go with we're just going to add an add instruction. How do I do RASM? We want -a x86, I think, b32, and just D on there. So 2 null bytes is an add, the byte reference, and then the the parameters are swapped. So it's memory, it's registered at memory. W bit is off, so it does a byte size. So like we should be able to encode this with what we currently have. So let's do another one then. Decode. So why don't we say so we'll set the cursor to input, and then we'll get the instruction size from the first call to decode, and we'll say cursor plus equals integer size, and then we'll call decode again with cursor, and we'll just fill it into output again. And let's say output is reinitialized to 0. Does that work? No, I guess it doesn't like it that way. So best to do memset. Memset is what? Void int. Is there mem clear? We'll just do memset. Okay. Then we'll pass in output and 0, and then size of output should be fine, I think. I don't know if we, I guess we do. Cursor. Okay, so we'll just clear out the memory first, because I think the way that our decoder works, it doesn't necessarily set everything off. It should be fine in that for the operands, well, right now we do set operands 1 and 2 for all of the instructions that we write, but that wouldn't necessarily be the case. If we had an instruction that had a single operand, then probably my decoder wouldn't bother to set the operand type of the other one. since if it's 0, it already defaults to none. I don't know, maybe that's a thing to go for later. Because that is more of just a minor performance difference. I should write a test for that if I want to do that later, though. Okay, so we're going to do a second decode, and the opcode this time needs to be add and the first parameter needs to be mod rm, and is it going to be a register? Yeah. And it doesn't have any sort of addition. I didn't miss anything, right? These are always a single thing with a potential displacement, so okay. And it's not going to have a displacement on this one. Reg EAX, and the displacement is 0. Okay. Then the other one, the other operand is OT register. And the actual register is AL. I think that's enough. Yeah. So we're going to go ahead and repeat this. We need to set and what have I done here? But I went non-const there. So I don't know. I don't think I have to like friggin' reacquaint myself on the const stuff, but or I guess it's not necessarily the const specifier, but if I have an array like this for input, if I change input, if I attempt to do something with input with like pointer arithmetic, I don't think that's how you're supposed to do it. Could be wrong. I mean, maybe like not necessarily wrong in the sense of that is how you're supposed to do it, but more like it's perfectly acceptable to do it that way. But I think my conception is I want this to always be the beginning of the input in a, be an array that covers the full input, but doesn't particularly matter, I guess. we're not using the size of that array anywhere. But I'm gonna go ahead and have a pointer type, an explicit pointer type that is what we modify with the pointer arithmetic. I feel okay about that. Okay, so these tests will probably fail because I am not, yeah, we got those two failed. In particular because I am not updating the size properly to deal with the mod RM stuff. So let's do that now. So we'll start the instruction size at 2. It says unused, yeah. Then if we're in one of these cases that has a displacement on it, we can see all of these in this case and all of these have a displacement. So we can just set these at the top of the case. And there's no displacement in this case. And only this line has a displacement. And we'll have to add one if we go in the SIB cases. But otherwise, so let's do like integer size plus equals 4. Okay. Let's just go ahead and take out that comment. And so for this first one, or this second case rather, of the mod byte, we get plus equals 1 and plus equals 4 for this case. Okay, now they pass. So we are correctly updating the instruction size. Then it's just those changes, right? Okay. So now we can go ahead and worry about the SIB bytes. And we can do like an OR with SIB 8 in a register. SIB disp register 32. Okay, just again, a couple of example cases that will hopefully cover most of the SIB situation. I think I need to consider this case. more. And what these cases represent. So maybe I can actually create, like, come up with what that instruction needs to be. Oops. All right, so we'll start off with something like this. And we want appendix B. Find the OR instruction. Okay, so there are options for mod RM other than these two, which again we'll have to deal with separately, I guess. We can, how did I specify it? Oh, and I guess I need to vary up the ordering there. So disp 0 is, so for this one we're doing register to memory. Okay, so that'll be, and we are doing a 32-bit, so that's on. So it's 09 to start with. Hey, okay, we already got the 09. Then we'll figure out our mod RM. And it's going to have no displacement, seems like. So this is probably just a 2-byte instruction. No, it's 3 bytes because we're going to have the SIB. So we'll fill that in later. So let's get there. We want this value, and it doesn't really matter what register we're getting. It's going to be the 32. So let's look for EDI. Oof. Yeah, so 3C for our mod RM byte should give us an SIB, and the register parameter is EDI. Then, oops, what am I doing here? What? Guess I was killing those buffers unknowingly. Okay, then in the SIB, what we wanted was a displacement of 0, so we'll be in this particular section, and I see. Okay, so let's start with 20. Right? Like, I want to know what this none scaled index is about. So 093C20. That is EAX dereferenced. So that's going to be equivalent to a 2 byte that is 38. Yeah, okay, so the none part just kind of means that because you don't actually have let me double check. So if we do not 20 but 21, yeah. So the base is the only part. There's no scaled index, which is interesting. That you can just sort of re-encode those. I don't know why that is the case. Maybe there's some details about the behavior of the machine, or just something about putting a scaled index of ESP makes no sense. I can see that. I mean, ESP, there are definitely, I think, I've seen code that reuses ESP. It seemed like it's not a great idea, but I feel like I've seen compiler output where ESP was more used as a general register in certain functions. So in theory it could be, but like there's probably no good reason to support it in the instruction set directly. Like the number of cases where you really want to use ESP as a scaled index rather than as the base is quite small. Not being able to use EBP as well, I guess it's not failing to use EBP because we've got it here, right? It's just EBP is sort of overridden so that you have a displacement. I wonder if this displacement adds to... Oh, so they're talking about mod. So they are talking about in the mod RM bit, or byte rather. These determine what size displacement you have. So when you've got 0, 0 in mod, and you've got the SIB for RM, then for whatever reason you still get a 32-bit displacement, but it's with the scaled index and not EBP. Interesting. So I think there's a few edge casey kind of situations, and maybe I should write tests for those. Let's do sub, and what do we want? A SIB or just SI? I don't know if I want to write it that way. See, and I want to say no EVP. My naming convention here is just quite bad. Should we do reg 32 SIB disp 8 EVP? And let's do add for reg 8 sib disp 32 EBP. Okay, so these three are going to be sort of one each. I guess we need 2 and 4. Oh, why was I? Oh, ugh. Okay, so it's actually still one each of these, and should we? I guess one thing we could do is like put each one of these categories of instructions per one of these guys and make them a multi-situation. So how do we want to go about that? Just do it in a for loop. Okay. Let's try this then. So output will be 0 and cursor will start at input, and we'll also have we got 0, 2, 4, 8. So we'll have a loop for all of these scales. Not my favorite to have it hard-coded like that. I guess I could say 4. Sure. Then okay, so we'll know the scale for the one that we're checking right now, and we'll say decode cursor output first mem set output to 0, and then at the end cursor plus equals instruction size. So, okay, let's not do the none because I think we will have those as separate tests, but we can go with EAX. So we'll do EAX, and then EAX, ECX, EAX, EDX, and EAX, EBX. No, we should keep the registers the same because otherwise we would need to encode those in the array structure that we have the scales. It's better to just keep the scales be the only thing that changes. So we could do EAX seems fine. Which means the first one is 01. It has no displacement. Okay. So this is the first one is 01. Then second one is 41, and it has scale of 2. All of these have no displacement, so actually we can do it this way. (4-1, 8-1, and C1. So those will be our 4 instructions that we're going to loop through and see if we get the right size out of them. And then we need the actual assertions inside of our loop. Okay, so they're all going to be OR instructions. The first parameter is going to be an SIB with SIB dot index, or let's do scale first, is just scale, whatever that is. Then register, let's see, the index is going to be EAX in all of these, and the base is ECX. And these need to be reg. Okay, and then we've got a register. It's 32 bits for the, let's see, we did 3C, which is EDI. These will be R2. Okay, and I think that should be good to test all of those, and we're going to just repeat this same thing. For the next two. But this one has it in opposite order. Okay, so first off, we need to switch up the opcodes. We've got an XOR. I'm going to worry about the opcode value later. Let's start with the mod RM. So we want an SIB with a displacement of 8. So one of these. One of this row here, and I'm just going to go with ESP, I guess. So, but it's actually AH because we're going to do W bit off. So it's an 8-bit register, but it's still 64. So okay, we'll have 64 for those. The register that we are dealing with is AH. the opcode is XOR, and I think these are probably all going to be 048C. No, they get into other values as you go up higher. So we did EAX, ECX. So let's do ECX and EBX, I guess. So 0B, 4B, 8B, CB. Okay. So we can just change all those, and then we can get the XOR byte. But again, I'm gonna, rather than keep skipping around in the manual, I'm also going to set up this one. It's going to be an SIB displacement of 32 and an 8-bit register. So we're on this line. Let's do DL. So that's 94 for this one. Oh, and we need to put those displacements in. Let's do, and this is going to be a 32-bit displacement, so 4, 5, 3, 2, 0, 1, and AF. And then here, we'll just do E4. Well, yep, I've forgotten to put the commas in. Down here as well. Nope, nope. Jesus Christ. Okay. Then let's put the displacement. Where's the displacement go? We have an SIB plus displacement. I think I need to improve the operand for, yeah. So we need an int 32t displacement. And I mean, you know, you could structure it so that this displacement field and this displacement field are basically the same, but I don't think that's really that meaningful. So let's leave that as is. Okay. Then it's going to be on the SIB. Int 32t, which is just E4. Output dot operand 2 dot sib dot displacement. And same thing here. And this time it's going to be AF 01 32 45. What have I done wrong here? Too many arguments provided? Okay, just client getting weirded out. Sometimes I have to reload the file and that does it. I think I didn't leave the space in the earlier one, so for consistency, I'll leave the space out. Yeah, that looks fine. We need to fix up the SIB bytes on this one. So we want a 32-bit displacement, so we were going to do 94 instead. And then for the actual SIB byte, we can do EBP and EDX. I didn't fix the stuff here, right? Okay, that's my bad. So for like 4B, 0B, 4B, it's ECX's scale is the index and EBX is the base. Okay, and then down here for the index, we're gonna want, what did we say we were doing? Like 2A. So the index is EBP and the base is EDX. Okay, and scale will be based on that stuff. So then, let's see, this one's going to be all A's. We got 2, 6, A, and E, probably. 2, 6, A, EA. Okay. Cool. And lastly, we need to go in and, oh, did we again need to double check? So with 64, AH is the register component. Yeah, for an 8-bit register. And this one's an 8-bit register as well, and we've got 94. So we're looking at DL. Okay. I feel like, yeah, now we can move on to the opcode byte. Let's see. First one is going to be SBB. The first one I'm going to find when I scroll down here. There we go. And we're doing register to memory. So we've got 1, and then the W bit is not set, I believe. We got reg 8, so it's going to be 1-8. Let's double check that with RASM. 18942A453201AF. So it should be basically SBB space D word EDX plus EBP time plus EBP, because it's just a scale of 1 rather, not, I'll have to fix that in the other ones. It's not a scale of 0 because that doesn't help when you multiply by 0. So it'll be EDX, and this is like D word EDX plus EBP times Should I do 6A instead of 2A then? Let's do that way. So EDX plus EBP times 2 plus this value will be the first parameter, comma DL. And it'll be not a D word, but a byte. So SPB byte EDX plus EBP times 2 minus that value. That's fair because that's a negative. And then DL. Okay, so my opcode like byte setting is correct. So let's look at the XOR ones. And XOR, we've also got, this time we've got memory to register. Okay, and I believe W is off because register is still 8, yeah. So we've got 3, 2. Oops. Okay, and let's try this third one. 3, 2, 6, 4, 8B, right? Yeah, E4. Okay, so we are going to find, we've got an XOR of AH, comma, word square brackets, and in the square brackets we'll have EBX plus ECX times 4 minus whatever this is as a negative value, plus ECX. Yep. Okay, cool. So my test should be correct. I suppose we can, let's go ahead and just like comment these out for right now. We'll get to writing those tests in a little bit. And I can do this one last, I guess, just in terms of validating. So if we say 093C C1, that should get us a OR instruction where the first operand on the left side is a D word square brackets ECX plus EAX times 8 comma EDI. Yep. Okay, cool. Then the tests fail, understandably, because we don't have any of the SIB logic implemented, but we do have now a pretty solid basis for making sure to implement all that stuff. And then we'll have to add the tests for the special case kind of situations and see. I mean, it's possible that the way that I end up implementing these will also get those tests working, but I feel like I've done enough writing tests right now and want to get back into implementing the code for those tests. All right, so we know the SIB byte is always just going to be 1 byte. Oh no, so it's 1 byte, but it could be with a displacement, or oh, because we already got the 1 for the displacement here, so it's just going to be an additional byte if we do the SIB in there. Then we want to call an SIB function, decode SIB with I don't think we need the actual instruction streams, because on this part we're not going to worry about the displacement part. I might have to refactor the code a little bit at some point as we add more instructions, and maybe it would make sense to decode the displacement along with the SIB, but the size of the displacement and stuff is determined by the mod byte, or the mod portion of the mod RM byte. So I guess it doesn't make a ton of sense to bother with it in a function that just does the SIB byte itself. There's nothing about displacement in here, and these displacement values are determined by the mod bits in the mod RM byte. So yeah, we won't worry about any additional bytes in here, and we know that this just eats one additional byte from the instruction stream. So we just want to pull out SS, index, and base, and we need to come back up here to see where those are encoded, I guess. It probably, I don't know if it actually indicates that encoding. It probably follows the same structure. Oh, here we go. Okay, so the scale factor is bits 6 and 7, which are the high bits, and 3, 4, 5 is the index, and then the base is the low bits. Okay. Oh, sorry. So you can do const un8t. Scale is SIB and we have 1, 2, 4. Do it that way, but it's probably simpler to just say, what is that? That is 6. No. It's gonna be C, right? I should have it over here, right? Oh yeah, I could just shift it over 6 bits. Why don't we do that? I think it's the same kind of structure as what we have in the mod RM byte. So the index, it said, was the middle bits. So that's going to be SIB and 38, shifted 3. And the base is going to be SIB and 7. Okay. Yeah, I know they're not used yet. So inster dot, and we just want a operand pointer. We don't need the instruction itself. Oper type. Does that work? Okay. Oper SIB dot. Why is the LSP breaking? I don't know. Should be pretty straightforward. Again, these are always going to be the certain register with the exception of the none case. So let's just go ahead and say base is equal to reg bits to enum w, and it's going to be base with true and size 32. Then index is also reg bits, index true size 32. We're just forcing those to always return the 32-bit register enums. So I think the simplest thing is to just go ahead and set those, and then we'll have additional if cases for the special columns and rows. And then we'll just set the scale to be nope, why am I doing it that way? It's powers of 2. Okay. Then why don't we, yeah, that's simpler. And I could probably do that in the for loop as well. I don't know why I'm being so dumb about that. Then let's do it in the same order. Offer sib dot scale is equal to 2 times scale. Sorry. And yeah, of course we don't have that. I want to do that. It's just pow, right? Okay, that feels fine to me. Then decode SIB, which is instructions plus 1 plus 2. No, I think just plus 1, yeah, because mod RM is where instructions is right now. Okay, so get that. I think we just do that for all 3 of these cases. Oh, of course, I do need and let's make this a const. Is that fine now? Okay. No, now it doesn't like it. we need to just dereference this. Okay. Let's see what that does to our tests. Well, it does not work because now we need to link with math. Jesus Christ. Make file. Okay. Is there... Oh no, I already clicked that the last time. We don't care about that one. Let's see. They can tell us about C flags. Whether there, I think there's like libs or something. But I'm so bad at makefiles. Extra C flags. Do I just put -L in the C flags then? -LM. Yeah, I don't want a directory. Ugh. Let's give it a shot with -lowercase-lm. Okay, that seemed to build. And they didn't work though. So let's see what we got wrong. On line 207, the operand type was not SIB. Interesting. 236, the type here should be register. We should have the direction switch. But we got 5. What is 4? So let's start with the first one, right? The OR that failed, where we expected an operand type of SIB. Oh, we need to do this to 2 instead of 1. Okay, getting somewhere, I think. 243, the displacement was actually 0. Right, because we actually didn't throw the displacement in there. Then I think we can do that. No. If That's for both those displacements. Okay. Because I think I had a moment where I was confused and I thought, okay, am I treating instructions as a 32-bit pointer so that when we add 2 to it, we are going up 8 bytes or something? But I think I would need to, whoops, oh shit, where's that? I think I would need to have moved the cast inside the parens with the plus. So I think we are adding that many bytes to the normal version of the UN8T pointer, then treating it like in this case, int 8T pointer and dereferencing it to put on the displacement. But that displacement is incorrect for some reason. But we're saying we expected 228. Oh, because I do need to say this is an NAT. I think. Here we have 32, but that's a 0, so that doesn't matter. And a uint. Should we make these uints? But I feel like I'm doing this wrong, how I'm doing these assertions. I mean, we're getting the right value, but the immediate itself is not a uint. Oh, the immediate is a uint. That's probably fine. But the displacement, I do have an int 32t of 44, but that's low enough to where that's not going to need to be sign extended when we then treat it as a 32-bit. I think that's just luck, maybe. This one is 44 when it really should make these different values to just try different stuff, but I think making this an 8 and in 8t should be sufficient, I guess. And then making this an int 32t. What is the other one? 264? So not this line actually, but the opcode needs to be SBB. Okay, I just missed that. All right, that made everything work. So it just happened that this is the first time we had a negative value in a 8-bit displacement, and because we keep the displacement itself as a 32-bit value, as an int 32, I was, for whatever reason, thinking I needed to cast it to a int 32t, but really we need to cast it to an int 8t. Make sure that it doesn't sort of consider this the same type because it's just a literal. So it's going to pick the type for us. So we need to force it to be considered an int 8t, which would mean that actually does get treated as negative. and this should have the 32-bit negative equivalent in it, my guess. Yeah, because we said actual is negative 28, so I would assume the high bits, like this has been sign extended from the original single byte. And then this one is already 32 bits, so it doesn't matter. So cool. Then let's do our additional tests. And we're not going to test every scale in these ones, I guess. I don't know. I don't think I feel like doing that complete of a test right now. Just feeling tired. I think I might not do the full 3 hours this time. So let's see. This one, the first operand type is going to be the SIB, and go ahead and copy these in. And so, so these, we should have a test for the none scaled index. We can do that for one of each of the different scale factor bits, because it's still got to be none in all of them. That's fine. So let's add that test in as well. Utest and compare SIB. So we can do it with no displacement, I guess. Disp 0, just to make it simpler. And then a reg, let's see, and a reg 8, just to, like, again, keep everything sort of trying out all the different varieties. Okay. So to compare, first one's going to be an SIB with displacement of 0, and let me double check, because I think I might have just missed the displacement on this, since we really should set it to 0, and we don't really need to cast it. And this one actually does need to be in a loop, so maybe I should copy the code from here. Do you recommend any reading material on C++ unit testing? I guess that depends on what is it you're trying to learn regarding unit testing. And hello, Speed of Light Pen. Thanks for watching. Is it, when you say C++ unit testing, are you thinking like, okay, I've done unit tests in other languages and I just want to know what are some sort of best practices for doing it in C++? Or is it like you happen to be working on a C++ project and you want to learn how to do unit testing as a more general, like, okay, so you've done very little unit testing. So, I mean, if possible, if you don't have to learn it in the context of C++, even though that might be your particular use case where you have a project that you'd like to use it with, I would say the material that's available for it and just the simplicity of using like a dynamically typed language means that something like Python would be a better choice. Java, if you want to go like, or C# certainly, if you want to go a little more statically typed, but still less of a pain than a C or C++. I just feel like I mean, there's definitely unit test stuff for C and C++, but I think if you're looking at like trying to find reading material for learning about how to do unit testing, that's going to be not the main language that you're going to find that material in. That is my experience. So if you know another language, basically, I would say try to learn it in that language because the principles are going to apply the same. And you're just trying to get the sense of how unit tests should work. And I want to be clear, like technically what I've been doing on the stream, if you've been watching, is not great unit tests. If you have JavaScript knowledge, unit tests for Node, and I would like look for stuff related to this idea of software craftsmanship. The manifesto, I guess. I mean, this is more general stuff, but unit testing as a discipline and the testing sort of mindset and test-driven development kind of stuff is, to me, fits in this category of programming that is like culturally within the concept of software craftsmanship or craftspersonship, however you want to say it, where it's about the development of the code itself and what that code as an object rather than as a tool to make the machine do a thing or as a representation of an algorithm. The code itself is a physical material that you have to work with as a programmer. If you have to refactor something, you have to deal with how the code was written, or if you have to understand some code, the naming choices, the organization, all of those things sort of fall into like software crafting, right? Where the software is your raw material and the purpose for that software is not besides the point, but it's definitely a different matter than what you were talking about when you talk about software crafting. And so unit testing falls into that category as a means to have an assurance that your code is doing what you intended it to do, which you could certainly achieve through non-automated testing, manual testing kind of stuff. But when you get into understanding unit testing, and especially the sort of software craftsperson mindset, you start to realize you can get to this level of like what I would consider TDD, test-driven development, where actually you want to write the tests that determine then what your code looks like. If I write tests to do a certain thing, and I only write code to implement that thing that I am testing, the tests itself have a driving relationship to the design of my code. Because if you just come at something from a blank file and you want to, okay, I'm going to write a program to do X, you can go, a dozen different routes to achieve that if you don't have the constraints of what, like, there's different, concerns that might become constraints that will define how your design actually works out. And if you aren't thinking about those ahead of time, your code might go in a direction that turns out not to be the way that would be ideal for how you actually need to use it. And the idea with the testing is you are putting those constraints up front. So I realize I'm talking about a lot of stuff and not actually giving suggestions, but I think maybe in a more broad sense, stuff from the like pragmatic press because that's a publisher that is started by these folks who are sort of like some of the earlier or like luminary kind of people maybe within the software craftsmanship movement. And I think they're going to have stuff around unit testing maybe, or just, let's see, yeah. So JavaScript, test driving JavaScript applications, maybe. That name makes me question. If you know anything about React, well, I guess you said Node, so that's more server side. But I would imagine test driven React could, like, especially if you have some React knowledge, or if you just want to sort of pick it up enough for the purposes of going through a book. They have test-driven development for embedded C and modern C++ programming with test-driven development. So I would look at pragprog.com. Just throw this link in chat for you. Pragmatic Press in general has a lot of books that sort of have this as the focus of this like craftsperson style, and there are definitely certain languages that are, I think, preferred in that community. Elixir and stuff. Yeah, I'm sure your university library will have it. And so the terms that I would say look for are things like test-driven development. I don't remember the specific books that I've used, and I mean my experience with it. So I worked as a game developer for my first sort of real programming work, and that was like my first exposure to unit tests, and it was very minimal because our game project that I joined the team on actually had pretty minimal testing, and I think just culturally our company was not great at unit testing. There was certainly none of the like test-driven design or test-driven development methodology and mindset. And then later I started working at a coding boot camp where we taught Ruby on Rails. And Ruby is one of these languages that is like was very heavily taken up by the craftsmanship sort of movement. It's not necessarily the one that everybody goes to these days. It's gotten out of fashion a little bit, but if you look at Ruby on Rails as a framework, it has a very strong testing credentials, let's say, or just like writing tests for all of your code is very much a part of the culture of building Rails programs. I say culture because like certainly you could build your Rails programs and not write tests. And in fact, the first one I ever wrote when I was actually still working at the game company, and that was my first foray into Rails, and I didn't really know enough about testing to even come to a conclusion of how I would test the code that I had written. So, you know, I wrote stuff in Rails that didn't have tests, but then later when we needed to teach it to the students because we were trying to do like the right thing in terms of teaching, that's how I sort of came to an understanding of it. And I feel like I didn't necessarily sit down and read a book for it. That's never been like as much as I love books and I have certain books that I'm like a big fan of, I find that that's not actually how I end up learning a lot of stuff. So I think, yeah, I mean, I would suggest these books, or at least, you know, look, I mean, don't necessarily just go out and buy a book, right? But see if you can find books about test-driven development at your university. For me personally, books that have a lot of exercises, or, you know, have a like you sort of learn by doing component to them exactly. And test-driven development is a perfectly like well suited to that kind of learning style. because what you can do is have a test. So you could start off with like somebody has provided a test for you, and then you need to write code that makes that test pass, which is a key half. When you're doing test-driven development, that's half of the work. Once the test is written, but it doesn't pass because the code doesn't exist or hasn't been modified properly, then you need to modify the code until the test passes. So you can start with that half, which is technically the second half of the cycle if you're starting it from the beginning. But if somebody else can give you those tests, because it's maybe you're going through a tutorial or, you know, just some sort of like the equivalent of CTF challenges, because I'm sort of in the mindset of like InfoSec hacking stuff, so I think about CTF challenges a lot right now. But like if you can find like, I don't know, maybe there's like learn TDD by example. It just is like, as a structure, it's incredibly well suited. Yeah, I'll throw this link into chat as well. It's incredibly well suited to actually writing code and doing the skill, not just reading about it in a book, in order to learn it. And so you could start with this, like, okay, let me just write code that makes tests pass. And then I can learn about how I should design tests for code that I anticipate writing. There's a different set of skills perhaps in taking a chunk of code that has no tests and then deciding what tests you need. That's probably the kind of skill that you want to have after you have gotten a better basis on writing the tests first, because it's easy to break down your code or your testing approach in the wrong sort of factors when you have a bunch of code already. And that code may not be written in a way that makes it well suited for unit testing. Like my code is actually not, these aren't really unit tests, I would say. These are they are testing a single unit that is called decode. So they are unit tests, but they're not high quality unit tests, I guess, because I could break down, I'm testing SIB related functionality by passing in real instructions that happen to be encoded to use the SIB bit. But I actually have a function, decode SIB, like I should actually have tests just for this function. But right now I don't have my test set up that way. And so that's my bad. If I was doing this in a TDD way, I would most likely have factored it a little better and had this be the focus of a bunch of tests. And, you know, maybe I will go back and refactor things along that route. But I think probably since I plan on rewriting this in Rust, I'm going to leave it as is and then try to do the like more high quality structure of the code in Rust. And it works right now. It's just, yeah, this is not the result of TDD. In part because TDD can be very difficult if you don't know what code you want to write. If you don't understand the structure of the program that you need to be creating, TDD doesn't do a lot to help you get there. And when I started this off, I knew I didn't really understand what the structure of the decoder was going to be. My initial pass at the code was a completely different approach to what I'm doing right now. And this approach is also going to change somewhat as I continue on, just because I'm sort of over time coming to a better understanding of the scope of the problem and how it breaks down into different elements. And so ideally, once I've solved it once in a bad way, when I go back and write it in Rust, I'll be able to solve it in a much more elegant way and be able to write the unit tests for that much more like comprehensively and more targeted at small units, because arguably, if decode SIB is its own unit, but it's being used as part of these other functions, then this is less of a unit test and maybe more of a end-to-end or integration test or whatever, where I am testing. I guess it's not technically integration because I'm not composing components as part of the test. They are fixed in their composition, but I'm testing multiple elements together, which is one of the design things that you want to avoid as much as possible with unit tests, at least. There are other kinds of tests where this is a test that you want to have all of the pieces put together and then see if it still works in that composition. And so these technically fit into that category more than a unit test, I would say. But I don't know. It's all, it still is testing what I've written, and I've still found bugs. Or in this case, I started going a little more TDD, and I started writing the test first and allowing that to be a sort of indicator as to whether or not I wrote the code correctly. But I, like earlier on my last stream or something, I found a couple bugs that absolutely should have been breaking some of these early tests, but they were still passing, and it happened to be like conveniently I was missing the cases where they were breaking, and they probably would have been more, I would have had better tests and tests that would have broken because those bugs existed if I had broken the problem down into smaller little functional units and tested those separately, rather than doing these composed together units as individual tests that are only testing a few different use cases, as it were. I don't know how much of this necessarily makes sense if you don't have that much exposure to unit testing, but yeah, I mean, maybe check out this page. I don't know anything about Learn It My Way, but the idea of just getting at least a small exercise in how to do TDD with FizzBuzz seems like a good way to start. And the nice thing is, test-driven development by example. And Kent Beck is a nice guy, or seems like a knowledgeable kind of guy. I don't know what language would be used in this book, and the cover makes me think it's maybe a decade old or something. It just doesn't feel like a modern computer cover. What was it? 2003, yeah. So I don't know, can we see, like, if I were going to recommend a very specific book to try to find in your university, I would say look for this book, Test-Driven Development by Example. And I would encourage you to try to actually code the examples that are talked about in here. It looks like this is probably Java. So, you'll have to do some translating for JavaScript, but I don't think the code is going to be complicated enough that translation would be difficult. I shouldn't say that because I don't know what your experience level is. But it's not going to be, hundreds of lines of code for these examples. Like, they're going to test a function that does a multiply by 2 or something, right? Like, very small functions tends to be the design approach that you end up with when you do the TDD approach. Is like, can you get a function that is 5 lines or less, 10 lines or less or something? And like, if you have functions larger than that, you should look at that and realize and have that be an indicator, oh, maybe I'm doing too much in this function. Maybe I should break it down into smaller pieces that I can test separately. So I don't, other than this one particular book, which I gotta say, I have not actually read it. I know the name Kent Beck he's within that sort of software craftsmanship community. And I feel like I have good thoughts about him that I can't necessarily place a specific thing. And it's a book about TDD that is by example. I can't necessarily vouch for the extreme programming stuff. Like there's definitely aspects of the software craftsmanship culture that had verged into like consulting snake oil kind of stuff. Just showed my postal code on stream. Oh, that's probably fine. I'm not anywhere near there. I'm not in the United States right now, so I don't know. People can, yeah, you can find out I live in Seattle. Thank you for the FYI, though. I should probably be a little more cautious about that kind of thing. Yeah, I appreciate it. So, and I think if you look around at like extreme programming and stuff, you can definitely find a lot of articles where people are talking shit about it, because like that and like Agile and Scrum and things that have followed it, there are definitely a lot of parts of that where it's like, oh, here's like a software development methodology that I can go to a large corporation and be a consultant for them, trying to sell them on this. You should make all your employees act this way or whatever, and pay me a couple $100,000 to tell you about that. That like, and I can totally understand it getting a bad rep from that. But the overall software craftsmanship community and culture and the fundamentals of TDD are real things, and they are useful, I would say. I don't use them as my like sole focus and understanding around programming, but they're an aspect of programming that I think has made me a better programmer, to understand them and to be able to apply them. And I'm sure there's a lot more that I haven't spent a lot of time trying to get good at these skills. You can definitely go down the route of like code katas, which is like a small problem that you would solve in TDD style, and you would like work on it for 10 minutes, half an hour in any given day, and then throw it away and do the same problem again tomorrow and see if it goes faster, or you come up with a better solution, or such and such, just as like a daily practice kind of thing. And I thought it was pretty bullshit to start with, but I had some good experiences on the couple of occasions where I said, okay, I'm going to take this problem that I've already created 5 versions of it, and right now I can't think of how and it's a small problem. It's not a very like large, it's like a tiny algorithm. And I've already done 5 versions of it. I can't imagine how I would come up with a different one the 6th time, but I'll go ahead and rewrite it just to try to keep up with this kata concept. And sure enough, that 6th time it was different, and the 7th time it was different, and the 8th time it was different. And I think I think it was called baseball. Did I call it baseball? No. Something ball? Sports ball. I think I did it in TypeScript primarily. And oh, that's fun. It's old enough that, yeah, I did 14 versions of it, I guess. And by the like towards the end, I started to realize I was basically doing the exact same program each time, so I stopped with it. But like what I did for the first version and what I have for the 14th version that solved the same problem are so vastly different. Like I've got 2 different files here. I've got 125 lines of code here and another 18 here. And then in this one file, 33 lines of code, does the exact same thing. Yeah. And the tests are a lot more reasonable. This is all the tests that I need to know that it does all of the behavior that I need it to do, versus the tests that I had in the previous one where I had integration tests with tons of test cases. I had a whole bunch of unit tests as well. Like it was vastly over-engineered. And this first version, I genuinely thought, oh, I did a really good job. Like I designed this well. I came up with good data structures to use, and I definitely followed like decent testing guidelines and have, you know, good test coverage, like absolutely complete test coverage. But doing the TDD approach in this repetitive kata style, basically I came to a much deeper understanding of what the problem was, what the algorithm I was creating actually was, and I was able to cut out all the nonsense effectively. There was just no reason to have all of that structure once I really deeply understood what the connections between all of the pieces were. And I made some real weird pathways in the middle. I don't know if it's I don't remember which ones it was, but granted I was on some of these very high on weed when I decided to do it again. And I had stuff that, I think this is the one where it's like I'm parsing the data backwards rather than forwards, because I started like drawing charts to come up with relationships between all the numbers and realized, oh, there's like this relationship that you can see if you parse it backwards rather than forwards and stuff. And I moved past that because I was just like, okay, let me come up with a better approach again. And eventually realized like, oh, you know, those relationships are real, but they're much simpler than I was making it out to be. So effectively, you could take this approach of TDD, and I'll throw this repo in there if you really want to take a look at it. It's a decent problem to solve. Like if you want to I did this in TypeScript, or you could certainly do it in JavaScript. There's no reason not to. I just wanted to practice TypeScript at the time. And once you have a feel for TDD stuff, or you might want to just use this as a example to try to practice TDD in the first place. But you can definitely, it's small enough that like by the, 10th time or whatever, as I started to hone in on the really good solutions, it wasn't taking me more than 20 minutes to type it all in. And I was not copying and pasting anything. I was typing every character myself. So, that was like maximum 20 minutes because I had it in my brain because I'd been doing it every day kind of thing. But the point is like TDD and the repetitive re-implementation of a piece of code really is a way to achieve a certain enlightenment about that particular piece of code. It's not necessarily the case that any given bit of code that you write is going to be worth that effort. Certainly this program means nothing to me. I don't need it, and I haven't really thought about it since I stopped doing it. But if there was a piece of code that was like, hey, I want this to be the best version of this that it could be, I think applying the like write it once, throw it away, write it again, throw it away, write it again kind of approach is doable. You probably have to take it a little bit differently when it's a large program. So I wouldn't necessarily try to write the x86 decoder program from scratch every day, but I might write one of the functions. I might write the SIB sort of decoder function from scratch every day, or maybe, a couple of them if that seems too small, and write those and write all the necessary tests for them every day. And I bet I would come up with a better approach on, version number 5 or 6 or whatever, just because it's a little bit of like, okay, your brain wants to try something different than like, that it's not really helping if you write the exact same code the second time, because then you're just trying to tell yourself that you did it perfectly originally, and that's probably not true. And additionally, like you have acquired knowledge of how to do the problem properly just by attempting it and not doing it as good as you could. So you will get better every time you do it, just sort of by osmosis, or subconsciously you'll get better understanding of the program, or it might be conscious. Sometimes you have those insights and it's very obvious. So I would suggest, try to get into the TDD mindset, and then also understand what its limitations are effectively, because like TDD is probably not a way to understand how to make code very performant. You can write tests that are trying to test performance, but unit test style and TDD style like development is not necessarily going to push you in the direction of factoring your program in ways that are best for performance, right? So that's a whole different spectrum of programming that, especially if you're working in embedded stuff, you might need to have those kinds of things in mind. How to be really resource efficient, basically. And it has not all that much to say about those things. Additionally, I don't think it has a lot to say on the topic of picking the correct algorithms from a algorithmic performance standpoint. So if you're looking at, what is the big O time and space complexity of this algorithm and that sort of thing, and what is my worst case and average case and all of that, I don't think TDD really is going to help you decide on which algorithms to use, or help you design algorithms that are super generic. It's more how to apply algorithms maybe in a specific use case, and how to structure code so that you have the best understandability, the least amount of unnecessary code, and are probably best positioned to modify that code in the future as as the needs of the software change. And that's really the core of the crafter, the software crafters kind of focus, emphasis, whatever. I see these as like the 3 pillars of programming, or the 3 foci. The software crafting kind of thing, which really ties into the human element of the code is a thing that human beings have to interact with, whether it be to read it, to understand it, to modify it, to work with it when they create use it to make another program, or to test it to verify that it works according to our requirements. Then the other 2 are the abstract algorithmic computer science side of things. That is probably the most visible element of programming from just for historical reasons, that's what people think about the most with programming, is like data structures, algorithms, and logic, and all these, you know, and like language stuff and parsing and all that. And then the third being like low level performance and machine focus oriented kind of stuff. I find that everything sort of has some portions of each of those three elements to it. And a lot of programmers are like more drawn to one of those three than the others, perhaps. So that's just, you know, sort of dumping my philosophy of programming that I've come to over the years. I wish you the best of luck on you know, learning about unit testing and TDD and stuff. Feel free to come back anytime. I mean, obviously you keep watching, but, you know, come back and let me know if you've made progress with that, and if how that's going. Always happy to take the time to share my opinions on stuff, and, you know, hopefully in a helpful way, because I don't know, I like to think that's part of why I ended up going for working at a boot camp for a little while. What was I working on? I want to write these additional cases. So we got this case where we have the no scale entry, and that's going to fail right now because these ones, the code that I have right now is actually going to select this as square brackets ESP. Square brackets ESP, but there is no such thing, so we need it to be reg none for the scaled index, and then I guess I'll put 1 as the, no, let's put 0 as the actual index value, or sorry, as the actual scale value. Doesn't really matter because the register is going to be reg none, but feels more appropriate to say 0. And this is part of the, like, what makes it difficult to write this program is I'm writing it without an actual use case for the output of the program. So the design choices that I'm making around how I want to structure the output are completely arbitrary. Like, do I want this to be a 1? Do I want it to be a 0 in this case? I don't know. 0 feels more appropriate, but I have no code that's going to use it, so there's no like definitive thing that is going to be better or worse because I made this choice a certain way, which is not the ideal scenario to be operating under. But I don't yet have a program that I would use this for, so I'm just going to continue on with it, and we'll need to just live with that for now. Yeah, I don't care. Okay. So operand type is SIB, the scale is 0, the index is going to be reg none, and then the base, we need to actually pick one of these, and we'll have a different scale. Oh, I'm in the wrong one actually. So scale is going to be 0 in all of these. Yeah. And index is going to be reg none. Then we need to find out what the, so we're going to do 0 displacement, was that right? Yeah. So we can take out the displacement, and then we got to pick a register column to use. And I don't think I did anything with ESI yet, so let's do that one. So that's going to be 26 and 66 and A6 and E6. Okay. And then again, no displacement. Oops. So we can just do it that way. Let's see. And it's an 8-bit register. And what do we want as the register? Can do BL. And so it's going to be 1C. That'll give us the BL register. And this is the SIB with no displacement. C. Okay. And we need it to be a compare instruction as well. We'll get to that later. I'm gonna finish filling out the rest of these. So we need this to say compare. Okay. So the scale for this one, we're doing displacement of 32 bits and no EBP. So we're doing this special case here. So I guess we could do the looping. And we'll have a no for the base in these. Okay, let's figure out what this actually looks like if we do this one, let's say. So if the mod bits are 01 with an SIB and the base is 101. We got 09, mod bits 01, 100, let's do 5C. So that'll either be a BL or an EBX. And then we will have scaled index, and I guess the base doesn't matter. So let's try EDI. So we'll do a 4F where, so the scaled index should be ECX times 2. And I think EDI won't show up in the instruction at all. But EBP will. Or no, it has to be this one, sorry. So 4D we can do. So in theory, yeah, because it's not actually going to add EBP into, let's try 40 and then 01 for the displacement. So it is EBP plus ECX times 2 plus 1. And then EBX for the OR, yeah, okay. So how is that different from if we do 4E? Where I think if we do 4E, then EBP is just going to be ESI. And everything else is the same. So they call this out as being different, but it doesn't feel like it is different. I mean, it's possible that RASM is incorrect, I guess. But I'm guessing this means that it should be dereference. Yeah, I don't think the square brackets here mean dereference something. Because that would involve 2 memory accesses for this one operand, which is, I think, out of the question in x86. So I think it is the equivalent of having EBP here, with the exception that if mod bits is 0, then there is no EBP being added. Oof. What else? Where else can I check? There is a. I need to look in my starred repos. So I star a ton of. Ton of like. Filter this? Yeah, let's see. Stuff related to reversing, and in this case, Zydus is the one that I was looking for. It seems like a pretty like competent disassembler engine, so I don't think I have it installed on this machine. Let's see. Scientific, Zydus, tag, okay. Or make. Yeah, I think I'm gonna trust their make file is not downloading some shit. Oh, it's CMake. Yeah, I don't know. Gonna just trust it. So this is one of the libraries that when I've gotten my version implemented in C, I want to start looking through their implementation in a lot of detail, because theirs is a lot more complete than mine, for sure. I mean, I'm probably not going to tackle 64-bit instructions at all and a lot of the SIMD stuff. Just going to keep it to the core set of stuff for now. But it's also intended to be very performant. So I'm very curious about that. But the thing that I want right now is the Zydus info tool, where I can give it some instruction bytes and it will give me all of these details. Well. Oh, it's capital Z, right? Zydus info. What do you say? -32. And what were the bytes that we had? 09, 5C, 4E01. Okay, so this is represented as D-word pointer, data segment, sure. ESI plus ECX times 2 plus 1 into EBX. Okay, that's all good. Then when we change it to, is it 4B? 4D, I guess. Okay. Yeah, it's the same thing. Okay, although it's now in the maybe stack segment. But I think that's just implicit based on the instructions used, and I'm not particularly caring about. I don't have anything related to tracking segments. I guess I will have to I'll add that to my output structure when we implement the segment override prefixes. So base index. Yeah, it doesn't seem like, other than if your mod byte is 0. So instead of, what did we have, 5C? Instead of 5C, if we do 1C, why is 1, oh, because it needs a, yeah, 4 byte displacement. So yeah, we just have a base of none in that case. Okay, so that's how you get a base of none rather than a scale of none. Guess that works. So let's try one of these instructions. I know I haven't fixed the opcode byte, so it's probably not going to come out as, it's not going to come out as a compare, but that's fine. So we do 181CA6. It's a SBB, and we have the base of ESI, but we have no index. Yeah. So reg9 for that. The displacement is 0. The scale they put as 0, so that works for me. And I need to assert, rather than just take out the assertion about displacement, I want to assert that it is 0. And then this ESI, I forgot to change that. Okay, so these tests should be, that's BL as well. These tests should be working. In fact, it should look the same if we have EX, or E6 rather, and 6.6. Yeah. Okay. So back to this, our scale. Yeah, we're gonna do the loop for all of these because the scale does come into play in all of these. What? Oh, whoops. Copy the wrong stuff. This is something that I've for a long time not gotten around to doing, but need to get better at keeping the multiple entries in the whatever the yank area is, whatever it's called in Vim, and the equivalent in evil mode in Emacs. Because I copy a thing and replace another thing, and then because it's sort of like swapping what is in the yank buffer, and I need to then copy again or yank again the original thing if I want to repeat copying it. But there's definitely just other key commands that I could use to get access to whatever that original thing I copied was, and I don't know what they are, and I have not learned yet, so something to work on for sure. Okay, but if I don't waste too much time talking about Vim stuff, I can get through this, I think. So we can say pow2 and I. Okay. Should go ahead and not copy this stuff because I need to maybe fix things here, and then I'll copy the fixed version. Like for example, swapping the order of these around. Making the right register. Nope. What was that about? Okay. So the second register, or the second operand, is the SIB operand. It's got a scale, and the index is not none. The index will be something. We'll pick that something, but then the base is going to be EBP. That'll be the case for both of these. And here, let's do EDI for the register. And the displacement is going to be 8. So A8, why not? That in. Okay. Then what we need to do is pick an SIB byte, which is in this column, and just pick whatever register we want. So let's do ECX. So 0D, 4D, 8D, and D and CD. Oops. Okay, and then we want to pick 8-bit SIB displacement with a EDI register. Eight-bit SIB, and EDI is the last column. Yeah, 7C. Okay, and we'll fix the opcode in a minute. All right, so these ones, register is going to be, let's do DH. And it's going to be an add. And this is a 32-bit displacement, so we'll need to add some bytes for the rest of the displacement. If we say DH with 32 SIB B4, wow. Okay, and then the actual SIB is going to be, again, something in this 5 column. We can pick 15, 55, 95, D5. Sorry, it was 55. Oh, it's not 2D, it's 4D. 9 and D. Okay, and then nope, comma. B9 and C7 and D4. B4, C7, B9, A8. Oh, and I forgot the commas. Okay. So DH register, index is not none. Index is what? EDX. And the scale, and it's got EBP as the base. Okay. And we did pick DH, right? Is that? Or it's 32. No, it's an 8-bit register. So yeah, DH, which we get with B4, which we put in there. Yes. Okay. I think I need to fix the opcode bytes and then we're good. Checking 5. Okay. So let's start with compare. No, let's start with ADC. ADC, we're doing a memory to register, and that's going to be a 0, and W is off, so 0, 2. Ooh, what was that about? What? Okay, don't be like that. Let's double check one of these. O2, B4, 95, A8, B9, C7, D4. So should be let's see, DH. So it should be add DH, comma, byte dereference of EBP plus EDX times 4 minus some fixed value. DH, comma, byte pointer, EBP plus EDX times 4 minus that. Yeah. Okay. Let's do this one again as well. 18. Oh no, I haven't fixed the that was add. But yeah, what did I have? I did have add in there. Did I mean to have add in there? Now I am confusing myself. I guess. I feel like I had an add already, but I guess not. I mean, I'm sure I have add in earlier tests, but not recently. Okay, that's fine. Now ADC, which I guess technically comes earlier. We've got memory to register. Memory to register is going to be 1, and then again in the register, so that's 1 bit on. So 1, 3. Let's try that. 1, 3, 7, C, CD, A8. So we should see ADC of EDI, comma, D word pointer of, this should not be none. Shit. 4D. What was the one that I actually put in though? CD. Last one. ECX is the register, I guess. So it'll be EBP plus ECX times 8, and then minus this small displacement. Okay. Let's see what's right. So yeah, ADC of EDI and a D word pointer of EBP plus ECX times 8 minus that value. Okay. And then last one will be this guy of sub. So to fix the opcode bytes. Be in here somewhere. Okay. Then this one was register to memory. So 2 and I think it was 32 bits. Yeah. So 29. Okay. So let's try Zidus info of 291C66. What we should see is not a compare, or did I wanted a compare, right? Or did I have a, no, I wanted a sub. Okay. I guess since I put in the opcode byte, it's going to be a sub. So we've got sub of a D word pointer where we have ESI, no displacement, no scale. So just D word pointer ESI, comma, BL. No. Jeez. It's like, did not fix this one properly. Oh, and I didn't change. Huh. Okay. Need to get better with that. I'm doing too many things at once and then skipping around and not completing the stuff. So we wanted a 32-bit displacement SIB. Let's do 8C. We had 1C. Is that one of them? No. 1C is up here. It's not a 32-bit displacement. Okay. Then 8C, and we want it to be, or no, oh no, it does have to be 1C. It's not a 32-bit displacement to have. Oh, I see. It is it's technically a 32-bit displacement, not an SIB plus 30. Like this one, when you have the EBP, does a 32-bit displacement. Okay, so 1C was correct there. And it just happens to also be 1C, but let's do not 1C. Let's do 24 or 3C, 2C. What do we want? Do 2C. Just don't want to change as much. So that means that the register is going to be EBP. And then displacement still 0. We got this 5-byte, and we're going to be one of these ones. That would be interesting. There's a sort of a, like an edge case of 25 for the SIB byte with a mod of 0. That means that we've got a no scaled index and no base, just a displacement of 32. So there's a few ways to encode that, because we could have also done a 101 for the RM rather than a 100. and that would have allowed us the same thing, I'm pretty sure. But we're not going to do that one. I don't want that edge case. So we'll do 35 in all of these. So and 35 gives us ESI. Is that already what we had? Yeah. Okay. We'll keep it with 35 then. I'll just change it up a little bit. Can do 05. We'll have EAX. Okay. We want 048C. Then scale is, we also need the scale here. And the index is not none. The base is none. The index is EAX. All right, let's double check in Zydus info. 29 2C 45 should be a sub of D word pointer EAX times oh, we need to put the displacement on. Okay, so we have that displacement. It's going to be 90, 88, 1A, 34. So that'll be a negative. Okay. No, I need the comma in there. That's what the issue was. Okay, so it's going to be a sub D word pointer of EAX times, what did I put? 45 times 2, and then minus that large value, or minus whatever that turns into when you 2's complement it and have it be negative, comma EBP. Why is this? Why did it expect the closing bracket there? Okay, so we got to put in 34, 1A, 88, 90. We have sub D word pointer of EAX times 2 minus that value, comma EBP. Okay, so I think all of our tests are written properly, and we've got failures on those last 3. And so I think the way to solve them is, actually, yeah, let's find the ones that are failing. We have no scale failing, even though I thought it had been passing before. Scroll all the way past all of this stuff. I guess the no scale one I added. Okay, never mind. Didn't realize it was new. So no scale. Let's look at the test that failed. compare, but that's not a compare instruction, I guess. Maybe, oh, I probably also forgot to set up, oh, gotta go through these as well. That's probably what my failure was. I thought I added 3 tests and I actually added 4, and I was like missing parts of fixing the second one and the first one. So compare is register to memory, and it was an 8-bit. So register to memory is going to be 3 and A. And let's double check that with Zydus info. 3A1C26. Okay, so we've got a compare of D word pointer, ESI, comma BL. No, it's switched around. Register to memory, right? Register with memory. I don't know if like compare has these written differently from what I would anticipate, but I thought the 1-bit here had to, or this like 2-bit had to be on, but I guess not. So it should be 939. That makes it the order that I anticipated. Okay. Let's just do that then. Okay, so still failing, but at a different point. I think, yeah, the scale is not 0 like we would have anticipated. Okay, that's fine. That's a thing that we want to fix. So so this is the SIB case where we have no scale, and there should be a none as well. So we can sort of do a very strict TDD approach of like, let's fix the one test that it said failed. There will be other tests in the same, there'll be other assertions rather in the same test that are going to fail, but we'll fix this first assertion, which is that if the index is 100 binary, then our scale should be 0. So if index is 100, opera sib.scale equals 0. Okay, and now we have a different failure because we had it fail first on 297 and now it is failing on 298, which is the register is not none. Well, that's also the case that if it's binary 100, then the index should be reg none. Okay, and now it's failing on 303. The register is not the correct register. It's not BL. We got 8 instead. That's not part of this stuff though. Did I write that wrong? Yeah. Because I want it to, oh, sorry, yeah, I want 3.8. This is for the 32, or the 8-bit register. Okay, that's my bad, the test is wrong. Okay, so those pass now. or this test is all passing. And we did just the minimal set of stuff to implement the testing of that, or the passing of that test, rather. Which is, you know, sort of the TDD style of like, okay, write as little as possible to get the next assertion that's failing to start passing. Okay, then let's look at 327. The base is not reg none, and that is, yeah, because in this case we are in the mod bits 0, so we should have a 32-bit displacement in the scaled index, but no base. So that is the case where I guess we need to pass in mod bits. To the decode function. Because otherwise, how is it going to know? All right, and then I think this is completely separate from the non-scaled index checks. So we'll just say if mod bits equals 101, or sorry, if mod bits equals 00 and base equals 101. In that case, we want to say it's op none, or it's, sorry, reg none. That did not help, or it broke. No, it just the same, or it's a different failure though. Okay. But we got a displacement of 0. Something down here failing. This is mod of 0, right? So I see. How do we achieve that? That's a tricky one. Okay, so the issue, it seems to be if we have a mod of 0, then this entry should be just do a displacement, but only if the SIB byte has an index of 101. Or it's not necessarily, we need to add a displacement, which we don't add on any of the, like sometimes the SIB will have a displacement and other times it will not in this particular case, it seems like. So how do we want to achieve that? Because we only decode it in this function. Then I guess what we could check is if operand 2 dot sib dot base is reg none, then turns out it was with a 32-bit displacement. And we can do same thing as over here. Oops. So this will be sib.displacement. Okay. Give that a shot. Well, it needs to be +2. Okay. Cool, that fixed that failure. And we've got one test that's still failing. 359. The displacement needs to be in AT. I think that's just wrote the test wrong. Hey, we got everything passing now. Okay, so yeah, the SIB stuff is, you know, in theory, like, I want to say it's working, but again, along the lines of what I was talking about when I was talking to Speed of Light Pen about unit testing, the approach that I've taken to testing in this has been sort of adding on instead of doing it as a test-driven development approach. So I don't have like a comprehensive set of tests for decoding the SIB byte. And I need to, I would, in the absence of that, and those sets of unit tests, or that set of unit tests rather, I would want to have more comprehensive tests before I could say definitively that the way that I am dealing with the SIB byte is completely correct. It feels like I've tested sort of all the different edge casey sort of scenarios, but I certainly don't have tests that cover all of them. Or certainly not all of the cases. I think there's one sort of edge case that we talked about where it's in like 25 or 65, A5, and E5, that you have no scaled index, and potentially if your mod bits are 0, you also have no base, so it's just a displacement. And you know, in that case, it's effectively the same as this other kind of way of encoding the instruction. I don't have a test that covers that, and I don't right now feel like writing it. But it feels like that would sort of work falling out of what I have right now. It's just going down certain combinations of branches, which is, now that I think about it, an interesting one thing. If you're still watching Speed of Light Pen, one thing that you might want to read about is the concept of like cyclomatic complexity, I think is the term, where if you have one if statement, right, you've doubled the potential code paths through your function. And if you have two non-nested if statements, now you've got 4. So I don't have tests that cover one of the scenarios where this is true and this is true, basically. And there are 4 different cases where both of these would be true, it seems like. based on how this particular function call plays out effectively. So, that's the sort of like, you could think about your functions in terms of that level of complexity and whether or not you have tests that accurately cover all the different code paths that you could have. Because if you do your standard code coverage tool, my tests right now cover every line of this function. We do have tests that go into this if statement, and we have tests that go into this one. But we don't have tests that go into both of them. And most code coverage tools don't have that kind of insight, I think. Probably that's understandable because it's one thing to think about it in terms of a single function, but then when you add all the functions and all the different if cases, like, you get that combinatoric explosion of how many different code paths are actually possible in this program, let alone like if you think about loops and stuff. So most code coverage doesn't really take the route of like trying to present to you what percentage of all the possible code paths have actually been exercised, because you're extremely unlikely to hit all of them, or even a decent percentage of them. But that's definitely a code path potential through this function that I am not hitting. But I think that's enough for today. We're basically at my sort of 3-hour standard mark for how long I want to stream on any given day, and I'm just sort of done with it today, I think. So I'm gonna go ahead and commit this code, and then what else? I think on the next stream, so we didn't get to adding more instructions, and maybe yeah, I think we'll just add more instructions in the next stream and let the necessary changes to support some additional instructions, additional opcodes rather, we will let those dictate how we refactor our code. Because I'm certain that the fact that I have the mod rm logic embedded in the function that is used to decode a certain category of opcodes or instructions for a certain subset of opcodes doesn't make sense, because that mod rm logic is going to be necessary for a bunch of other instruction opcodes that don't fall into that same category and so don't need the other code that's in that function. So we'll refactor that. And then, yeah, I don't know. I don't have any thoughts at the moment. My brain is a little bit fried around what will come after that. But I think we've gotten through so much of the core elements of the original x86, or let's say the i386 instruction set, because I haven't really done anything with the 16-bit situation at all. We've gotten through a bunch of those. We'll eventually move into the 2-byte instructions. We'll need to talk about dealing with prefix bytes and that kind of thing. But I think those will make more sense after we have updated the opcode parsing logic to handle more opcodes. It might be more obvious how we fit in parsing out prefix bytes and stuff. And we'll need to expand our data structure to hold the additional information that would be given to us out of that. So, yeah. I think that is the next steps, and that's going to be on next Tuesday. So I guess I'm only working on this Tuesday, Thursdays. But tomorrow we go back to hacking practice with the Nightmare course. And the Nightmare course, we've got one left in the sort of anger category, and then we're going to move on to the ROP category. And we've done some ROP stuff earlier on. when I was doing Nightmare Course hacking practice streams. But we will get back into ROP, and there's just, like a dozen, maybe dozen and a half challenges in that category, and might even throw in some ROP Emporium stuff and just keep doing tons and tons of ROP related exploits, and then we'll move on to heap eventually. That's probably still a week or two away. And then over the weekend, as a little tasty little treat, I'm gonna get back into Try Hack Me. I did it one back on last Sunday, had some fun, and we've got more rooms to get through in Try Hack Me, so join me on Saturday and Sunday for that. Same general time. It's all on my schedule page, so check that out if you are interested. And again, thank you for watching. If you're watching the live stream or the VOD, and I'll see you next time.